Okay, so this week's topic is going to be logic and Venn diagrams. And logic is a pretty fun topic. So I hope you guys like this topic. So I'm just going to go over a few common types of logic problems in math competitions. So the first one is like order. So hold on. Okay, sorry, I had to change my audio. So the first question, Alexis, Britt, Carol, Danielle, and Elizabeth are waiting in line. Alex is behind Carol but ahead of Danielle. Elizabeth is ahead of Britt but behind Carol. Danielle is ahead of Britt. Who is first in line? So you guys can try this question first and I'll explain it later.
Can you please make it a bit larger?
Okay. Is that good?
Yeah.
Okay, so if you will try me the answers, I'm going to explain now. So first of all, we can just use their names. Instead of writing their names, we can just have A, B, C, D, E, A, B, C, D, and E. So Alex is behind Carol, but ahead of Danielle. So Alex is here. Alex is behind Carol and ahead of Danielle. So this would be the order of them. So Elizabeth is ahead of Britt, but behind Carol. So, and then we also have Danielle is ahead of Britt. So we don't have much information about the people in the third sentence. So I want to do this one first. So Danielle is ahead of Britt. So that means Britt is going to be here. And now we just have to find where Elizabeth is. So Elizabeth is ahead of Britt, but behind Carol. So she's in the middle here. So let's just say she's here. So that means Carol will be first. So okay, we move on to the second question. There are 3 boxes with different colors, red, yellow, and blue. One apple is in one of the 3 boxes. Only one of the following statements is true and the others are false. 1, the apple is in the red box. 2, the apple is not in the yellow box. And 3, the apple is not in the red box. Which box is the apple in? So I'll give you like a minute to try it. Okay, so I want to explain it now. So there's only one of the statements is true. So that means there's 2 false statements. So 1 and 3. The first one is the apple is in the red box, and the one is the apple is not in the red box. So those 2 statements contradict each other, which means one of them has to be true and the other one has to be false. So that means we don't know which one's true or false between 1 and 3, but we do know that there has to be one more false one, which means 2 will be false. So the apple is not in the yellow box, that will be false, which means that the apple is in the yellow box, which means the answer is yellow. Okay, next question. Each of the 3 marbles A, B, and C is colored one of the 3 colors. One of the marbles is colored white, one is colored red, and one is colored blue. Exactly one of these statements is true. A is red, B is not blue, and C is not red. What color is marble B? Okay, so I want to explain the question now. So let's assume that the first statement is true. So A is red. So that means C is not red, which means that 3 is also going to be true. So we know it can't be the first one because then there'd be 2 true statements, and it says that only one of them is. So it's also the same with the third one. If 3 was true, that means C is not red, and that means it is true for A to be red. So that means we can assume that 2 is the true statement. So if 2 is true, then that means 3 is false, which means that C is red. And that also means that 1 is also false. It means that A is not red. But that also means that B is blue. So that means the color will be white, blue, and red. So we only need to find for B. So we'll get, I messed up. Yeah, sorry. That means B is blue. B is not blue. I said B is not blue. Okay, so B is not blue, which means that, so B is not blue, which means, and A is not red, which means C is already red, which means that A is blue, and yeah, B is going to be white. Sorry, I messed up there. Okay, so next question. A turtle crawls up a 12-foot hill after a heavy rainstorm. The turtle crawls 4 feet, but when it stops to rest, it slides back 3 feet. How many tries does the turtle make before it makes it up the hill? So just saying when it gets to the top of the hill, it can't slide down anymore. Okay, so a lot of people tagged me the answer, and I think a lot of you guys are getting confused with this. So I'm going to explain it. So yes, every time it makes a attempt going up, it only ends up going up 1 foot. So technically, it would go up 12 times because each time the turtle goes up 1 feet. But actually, so let's say I said 12 minus 4 is 8. So let's say it takes 8 tries to get like here. Now on the 9th try, it will go up 4. So it would actually be at the top already. And once it gets to the top, it can't go down anymore. So it would go to the top and it would just be there instead of sliding back down. So it would actually only take 9 tries. Okay, so I'll explain again. So let me erase this. Okay, so most of you guys are saying that it takes 12 tries. So when it gets to the top, it can't go down anymore. So so let's say here is the hill. So it goes up 4. So let's say it comes here, but it goes back down 3 feet. So to here again. So that means that the turtle went up by 1 foot. So it would continue going there. And let's say here, this is the 7th try, it would be around here. So it would go up 4. So it would be at 11 feet, but it slides back down 3. That means it would be back at 8 feet. Now at 8 feet, it goes up 4. So it would actually be at 12 feet there. And once it gets to the top, it won't slide back down. So it would only be 9 tries. As I want to explain the next question. A jeweler has 4 small bars that are supposed to be gold. He knows that one is counterfeit and the other 3 are genuine. The counterfeit bar has a slightly different weight than a real gold bar. Using a balance scale, what is the minimum number of weighings necessary to guarantee that the counterfeit bar will be detected? So this one's a bit hard, so
what is like counterfeit and genuine?
Okay, so the counterfeit one means it's like a fake one, and the genuine one is like it's the real one. Irene, do you have a question?
I don't really understand this problem.
Okay, so I'm just gonna like reword it. So the jeweler person has 4 bars that are supposed to be gold, and they all look the same, but there's one. Okay, so there's 3 of them that are real gold, but there's one of them that is fake gold, and the fake one weighs slightly different than the real one. So using the weight scale thing, how many times you have to weigh it to guarantee that you can find the fake one? Okay, so some people are getting a bit confused, so I'll just explain it. So we have 2 cases. So let's say you first take 2 bars. So let's say bars, this is case 1. You have bars A and B. So
if they weigh equal, they're like real gold, right?
I'm sorry, what do you say?
So like if A and B, they weigh the same, they're real gold, right?
Yeah. So now that means C and D must be, so the first case is that the first 2 are the same weight. And that means C and D, one of them is a fake one. So let's say you replace B with C. Now, if the weights are different, that means C will be the fake one. And if C, A, and C are the same, that means D will be the fake one. So in the first case, there's going to be
3 tries.
What?
There's a minimum of 3 tries or 2 tries?
2. So you have A. First, you test A and B, and then after that, you can test A and B, and then after that, you test A and C.
But what if you get lucky and you get you find that B is the fake one?
Oh, well, okay, so that is going to be the second case. So the second case is that the first two are different.
So either A is a fake one or B is a fake one.
Yeah, so A is the fake one or B is the fake one. So now what you can do is that means C and D are both real ones. So you can replace, we're not sure if A or B is the fake one. So we can just take out one of them and let's put C there. So if C is there, C is real one, so we know that. So if they weigh the same, then that means that B will be the fake one because those two weigh the same. But if A and C are different, that means A will be the fake one. So for this case, it also takes at least 2 tries, which means that the answer will be 2.
But then how do you know that it's C that is the wrong one?
For the second case?
Yeah.
So you test A and B, and one of those, there's only one that's wrong. And if you test A and B, you'll know that one of those are going to be, and if they're different, that means one of those are going to be wrong. Because if both of them are right, then that means they would weigh the same.
But then if like B is the fake one, then wouldn't you have to try like 3 times?
Well, if B is the fake one, so if you test C and they weigh the same, and that means B is going to be the fake one because C is real and A, you don't know if it's real or fake, but if it is real, then that means A is real, but because it was different when you tested it with B, that means B would be fake.
Okay. Logic is kind of hard.
Yeah, it's a bit confusing.
Or you can't say kind of, but really hard.
Okay, this next one might be a bit hard. So,
is this the hat problem?
yeah. So this is a pretty common question. So there's a box of 3 hats, 1 black and 2 white. Andy and Betsy, each very smart and very logical, each place a hat on his or her head while blindfolded. One by one, each child removes his or her blindfold and without using mirror, gets 1 opportunity to guess the color of the hat on his own head. If any of the 2 guesses correctly, everyone gets to go to the park. First, Betsy removes her blindfold. She sees the hats that Andy is wearing, but admits that she is unable to discern her own hat color. Then Andy says, I can answer with my blindfold on. I know what color hat I am wearing. What color is Andy's hat?
I think maybe Andy's hat is white because if Andy's hat is white, Betsy doesn't know if her hat is black or white. But if Andy's hat is black, then Betsy would know her hat is white. So I think Andy's hat is white.
Yeah, so
it is white?
Yeah, so I want to just re-explain what you just said. So if Andy is wearing a black hat, there's only 1 black one, which means that Betsy knows for sure that it has a white hat. But if Andy has a white hat, then there's 1 black one and another white one left, which means that Betsy doesn't know if she has either a black hat or a white hat, which means that Andy must have a white hat. Jessica, do you have a question?
And how is Andy supposed to like remove see Betsy's hat with his blindfold on?
No, he just like guesses what hat they have because through logic you can tell that he has the white hat.
Oh. Thank you.
Okay. Now the last question is going to be a bit hard for the logic section. 3 friends, math teacher Mr. White, science teacher Mr. Black, and history teacher Mr. Redhead meet in a cafeteria. It is interesting that one of us has white hair, another one has black hair, and the third has red hair, though no one's name gives the color of their hair, said the black-haired person. You're right, answered Mr. White. What color is the history teacher's hair? So this one's a bit tricky, so you can try. Irene, do you have a question?
I just have a non-necessary question, but I have seen all the questions you gave me before. Like one of them was in one of the academies, and one of them was in our English classes, and then the rest are all in riddles.
Oh, that's cool. Okay, so
wait, can we give some more time? I'm still thinking.
Okay.
Wait, does answer white means he is having white hair or Mr. White?
White means Mr. White.
Oh, okay. So now I know that the person with the black hair is either Mr. White or Mr. Redhead, and Mr. White must have does not have any white color. So either the white person is Mr. Black or Mr. Redhead. Let's see. I don't know if she already said it, but when it said you are right, answered white, is it the one with white hair or Mr. White?
It's Mr. White.
I think maybe Mr. Redhead's hair is black. I figured it out.
Okay, you can tell me the answer.
Like in the chat?
Yeah. We're finding the color of Mr. Redhead's hair.
I sent it to you.
Okay. Okay, so I'm going to explain it now. So I want to use a different color. So a red line means that it isn't right. So we know that the name of their names and the color of their hair are different, which means that Mr. White can't be white, Mr. Black can't be black, and Mr. Redhead can't be red. So we see here that the black-haired person, Mr. White answered the black-haired person, which means that Mr. White can't be black. And that means Mr. White, because Mr. White can't be white or black, Mr. White will have to be red.
Wait, so Mr. Redhead is black.
Yeah.
So then it leads to other possibilities, and then we know the answer. Like, that's how I did it. I just, because White can't answer 2 times, so he cannot be black, then it must be red. And then Mr. Black, he must be red or white, but then Mr. White is already red, so then he must be white, which says Mr. White has to be, Mr. Red must be black.
Yeah, so we'll find that Mr. Black has white hair and Mr. Redhead has black hair, which means we're finding for the history teacher, which is Mr. Redhead, which means the answer will be black. Okay, so move on to the next section. This section is going to be sets and Venn diagrams. So I'm just going to go over a few terms. So first, a set is any well-defined collection of objects. And the objects in the set are called elements or members of it. So for example, a set could be 1, 2, 3, for example, and then the 1, 2, and 3 are elements of the set. So the next subsets. A subset is a subcollection of a set, and we use this notation to describe it. So, for example, a subset of 1, 2, and 3 could be 1, 2. And then proper subsets, if B is a subset of A and A is not equal to, and B is not equal to A, B is a proper subset of A. So basically, subsets can include the set. So a subset of 1, 2, and 3 could be 1, 2, 3, but that would not be a proper subset. So a proper subset would be all the subsets of the set except for the actual set. So the universal set, it's denoted by that symbol thing, and it's the set that contains all of the things. So let's say A equals 1, 2, 3, and B equals 1, 4, 5, then that means A, B equals 1, 2, 3, 4, 5. It would include all of the elements there. And then lastly, we have intersection of sets. So the intersection of sets A and B, written as A, that thingy B, is the set of all elements belonging to both A and B. So here, we're going to use the same example. It would be the elements that are in both A and B, which would be 1 because they both have 1. So it would be 1. So here are going to be some formulas. And I'll explain these first two later in a problem. I'm just going to show it to you. So A union B is equal to A plus B minus A, that thing B, And the same, it's pretty similar for, oh wait, that's supposed to say 3.
Wait, I have a question. What is that upside down U stand for?
It stands for intersection of sets.
Intersection of sets? Oh. But like if we need to know what the set numbers are, how are we going to solve that? Because each set probably has like not one number.
Wait, so for this example, I used the previous example here as the sets A and B.
Okay.
So the union formula for 3 sets is A union B union C, which is the union of all of those, is A plus B plus C minus A intersection B minus B intersection C minus A intersection C plus A intersection B intersection C. So I'll explain that in a later problem. So the next one is going to be the number of sets. So the number of subsets of a set with n elements is 2 to the power of n. So this is going to be an example. So how many subsets does C, H, E, and P have? So there's 5 elements, which means it'd be 2 to the power of 5, which equals 32. And the number of proper subsets is basically the same thing, but you subtract 1 because like I said before, the proper subset does not include the original set. So you would subtract that 1. So Julia, it would be 2 to the power of 5 minus 1, which equals 31.
Wait, can you give another example? Because I'm kind of confused about this part.
The proper subsets?
Yeah. And like the number of sets.
So basically, you just find the number of elements in the set. So here, C, H, E, and P has 5 elements. So the number of subsets would be 2 to the power of 5.
Okay.
And then for the proper subsets, it would be 2 to the power of n minus 1, where n is the number of elements. So here there's 5 elements, so it'd be 2 to the power of 5 minus 1.
Wait,
Can
I just write these stuff down?
Okay. Irene, do you have any question? Do you have a question?
Mark, if it has 6 elements, would it be 2 to the power of 6?
Yeah.
Okay.
Yo-Yo, tell me when you're done.
Okay. I'm just writing down these formulas and stuff.
I screenshotted. They're really confusing.
Yeah, are you done?
Okay, I'm just going to screenshot.
I can keep it here. I'll just move on to the next question. I'll move it up a bit. So I'll just start the next question. So consider the set A equals 1, 2, 3, 4, 5, 6, all the way to 57. How many are neither divisible? How many of the elements are neither divisible by 3 nor 5? So this question is going to use this formula up here. I'm just going to write it down.
Wait, so how am I supposed to use that proper subset stuff?
You don't need that. You don't need that in this question. It's just the formula.
Is B a set too?
Okay, so this question, I'm going to use a different variable because A is already in a variable here. So I want to use a different variable here. So I'll give you guys a hint. Let's say C is equal to the numbers divisible by 3. And B is the numbers that are divisible by 5.
Numbers divisible by 5 and 3 between these things. Oh. Can you wait a moment? I'm just going to solve it.
Okay. Okay, so we're kind of running out of time because Jennifer still want to explain a homework problem later. So is it okay if I start explaining this question?
Yeah.
Okay, so let's say C is the set of the elements that are divisible by 3. So it would be 3, 6, 9, all the way to 57 is divisible by 3, 19x. So I actually go up to 57. So the number of subsets within this, 3, 6, 9, all the way to 57, you can divide everything by 3 and you'll get, there'd be 19 subsets for C. So C equals 19. Yeah, so then we have to find the number of elements that are divisible by 5. So we'll have 5, 10, 15, all the way to 55.
So that's 11 numbers.
That would be 11, so B equals 11. And now I have to find the intersection of C and B. So C and B, we have to find the number of elements that are divisible by 15 because 3 times 5 is 15. So I'll just have 15, 30, and 45, which is
3 numbers.
3. So using this formula, we'll get 19 plus 11 minus 3 equals 27. So that is the number of numbers that are divisible by 3 and 5.
Well, then
3 and or 5. So we just subtract 57.
Oh, I get it now.
Yeah, so
57 minus 27, which is 30.
yeah. So always just remember to check what the question is asking for. Okay, so we're going to move on to the next question. So every member of a math club is taking algebra or geometry, and 8 are taking both. If there are 17 taking algebra and 13 taking geometry, how many members are in the club?
Is that like it says 8 are taking both? So then is the 8 already added into 17 taking algebra and 13 taking geometry, or we have to add the or we have to add it in there?
Can I tell you how I solved it? Charlotte?
Sure.
I wonder if it's the correct way, but since there's 17 and 13 taking geometry and there's 8 in both, so I did 17 plus 13, which is 30, and 30 minus 8 equals 22.
Okay, yeah, so
doing it.
Yeah, so let me just write it down. So let's say algebra equals set A. Algebra equals set A and geometry equals set B. So from the formula over here, we have oops. So we have A plus B, so 17 plus 13 minus the intersection of them, which is 8, we'll get 22. Okay, next question. At Asheville Middle High School, 30% of the students in the math club are in the science club, and 80% of the students in the science club are in the math club. There are 15 students in the science club. How many students are in both clubs? So this one might be a bit confusing with the percents and stuff. So just try and I'll explain it later. Okay, so we're kind of running out of time. I'm just going to explain it. So we're going to use the same formula again. So 80% of the students in the science club are in the math club. So I'm just going to draw a Venn diagram. Over here is science, over here is math.
There's 12 in the common area, and that's 30% of the students in math club, and 80% of the students in science club are the same number.
Yes, so we can use that. So 80% of 15 is 12, which means there's 12 here and 3 over here. And then we have 30% of, let's say M is the number of people in the math club. 30% of M's, which is 3/10, equals 12. So we'll end up getting M equals 40. Which means that 28 people take only math.
Wait, but aren't we finding that 12? Wait, what is this problem asking about again?
Oh wait, sorry, the question got cut off. So it's actually asking for how many, well, it's asking for how many students are in the clubs combined.
Oh, and the clubs combined. Okay,
So
then.
usually you would,
which is 43, I think.
yeah, sorry, it was like written a bit confusing. So you just add these up, and usually you'd use a formula, but there's a Venn diagram, so it's easy to visualize it. So that means it would be 43. Okay, so I'm just going to quickly explain these last two questions. So out of 22 people Out of 22 students surveyed on ice cream flavors, 12 like chocolate, 5 like only strawberry, and 6 liked vanilla. If 3 like chocolate and vanilla, how many students did not like any of these flavors? So here there's 3. So if 12 like chocolate and 6 like vanilla, then that means, hold on. So here, this is going to be chocolate. This is vanilla. So there's 12 here and 6 here and 3 in the middle. Which means that there's going to be 3 who only like vanilla and 9 who only like chocolate. Now there's going to include strawberry. So this circle over here is going to be strawberry. Oh, sorry, I'm answering someone in the chat. Okay, sorry. So over here, the people who only like strawberry, there's 5 over here. And we don't really care about these intersection stuff because it's already included in chocolate vanilla. So that means the union of chocolate and vanilla, it's going to be 9 plus 3 plus 3, which is 15. Add 5, 20, and then that means there's going to be 22 minus 20, the people that don't like any of them. Okay, so last question. There are 100 students in a class. 75 of them like to play basketball. 80 like to play chess. 92 like to sing. 85 like to swim. At least how many students like all of the 4 activities? So I'm just going to quickly explain it.
Wait, how do you draw these 4 circle Venn diagrams?
So this question, you actually don't really need to use a Venn diagram.
Oh. I use a formula?
No, so let me just explain it. So
or maybe I could do like 75 plus 80 plus 92 plus 85, then 100, that large number minus 100.
Actually, I'm just going to explain this question. So we can first add 75 and 80. And that would mean that there'd be 155 people who like basketball and chess. But that's like too large. So if we subtract 100 from that, we'll be left with 55.
55 people like both of them?
At least, well, yeah, at least 55 people like both. And then here we do the same thing with singing and swimming. So 92 plus 85 equals 177, I believe. And subtract 100 and you'll get 77.
So you do 77 plus 55?
Yes, so you'll do 55 plus 77 minus 100. And you'll be left with 32 people at least 32 who like all four. So we don't really have time to do the Kahoot today. Jennifer, you said you're going to explain a homework problem, right?
Yeah.
So let me give you a screen share. So okay, so I think you can share screen now.
Sure. So we're given from last week's homework that a and b are positive integers and a squared minus b squared equals 143. And we're asked to find which values a can take. Well, as it was said from last week, a squared minus b squared can be equal to a plus b times a minus b. And you could see that by FOIL when you use the distributive property and so on. And we're given that that will equal to 143. Now, since a and b are positive integers, that means that a plus b also has to be a positive integer. And also, a minus b has to be an integer. And so actually a positive integer, since the product, it should be of two positive integers. And then if you try out 143, you could see that it's either 1 times 143 or 11 times 13. And since b is positive, a plus b will be the larger factor. And as you can see, there are two cases. And for each of these cases, you can solve them to get a value of a. For this one, you'll get a is 72. And for the second case, you get that a is equal to 12. And for those who are curious, b here is 71. And b is equal to 1 when a is 12. So therefore, there are two values that a can take. Got it?
Okay, so I think we're done for today. So I'll post the homework later and see you guys next time. Bye, everyone.
Bye. Thank you for keeping.
Bye.
Bye.